Okay, welcome Algebra 2. We're going to be looking at absolute value, section 1.2. This section will go over the definition of absolute value, but also how to solve absolute value equations. So pay close attention here. It's not hard. There's just a process you need to learn. So let's get to it. Okay, so what is the absolute value? What is the definition of absolute value? Well, let's just start with the question, how big is negative 10 and how big is positive 10? What's the answer to both of those? Well, if you were to get out there and measure them, they'd both be 10. Just one would be negative and one would be positive. You could kind of think of the negatives as being red and the positives as being green. So we might have 10, you know, red apples, for example. Those might represent negatives. And then we might have 10 green apples. Those might represent the positives. But if we're just asking how big, I don't really care whether it's green or red. How many apples do you have? We just say 10. All right, let's look at this next slide. So here we have the red and the green. These represent algebra tiles. Maybe you saw those in middle school or Algebra 1 when you took that. So how big are both of these? So how many red do we have? Well, there's 10. And how many greens do we have? We have 10. So if we don't care about the sign, um, sometimes the number can be useful here if we don't care about the sign. So what about this here? Why do I have this on the screen? Well, absolute value is where you don't care about the direction or the sign. Don't care about the direction of your sign. Just want to know how far away are you from, where you started, for example, on your map. So the absolute value is represented by these goalpost things, these vertical lines. Absolute value of 5 is how you pronounce that one in the upper left corner. Absolute value of 5. So if we literally don't care about the sign, what would the absolute value of 5 be? Just positive 5. Now the next one, the way you pronounce that is the absolute value of negative 5. So again, if I don't care about the sign, what would the answer be? Well, once again, 5. Now absolute values also are groupings symbols. So we kind of have to jump inside and sometimes and do what's inside first. So this first one is the absolute value of negative 7, whereas the second one there is the absolute value of positive 7 because 2 minus 9 is negative 7 and 9 minus 2 is positive 7. All right, so what's the absolute value of negative 7? 7. What's the absolute value of positive 7? 7. So these are both 7. Absolute value of negative 7, absolute value of positive 7, all is the same thing as 7 because, again, absolute value just means, hey, I don't care about the sign at all. All right, let's move on here. Now, in a lot of textbooks, maybe you've heard this before. Absolute value is sometimes defined as the distance from 0 on the number line. Distance from 0 on the number line. Okay, so here's 0 on the number line. Let me highlight it for you. Here's 0 on the number line. So then you could ask, okay, so what is the absolute value of negative 2? Well, how far away is it from 0? It's 2. So the absolute value of negative 2 is 2 because that point is 2 units away from 0, sort of like home base. So how far away is 3 from 0? What's the absolute value of 3? Well, it's also 3. 3 units away. Okay, so that's another definition of absolute value. Remember, absolute value is where you literally don't care about the sign. All right, let's move on here. Now we have a real world application. So Susan's walkie-talkie has a range of 2 miles, and Susan is traveling on a straight highway. Okay, so here's the highway, all right, and she's traveling along, and she's at mile marker 207. Now let's go back up again. So she's got a walkie-talkie and it can go 2 miles in all directions, any direction, left, right, north, south, east, west, whatever it is, 2 miles. Using an absolute value equation, find the minimum and maximum mile marker from 207. Well, let's just think about this. Couldn't she go 2 that way or 2 this way, right? So 205 over here, and 209 would be the furthest away that someone could actually hear her. Now, the absolute value equation would be the absolute value of wherever she's at, we'll call it x, minus the middle. That absolute value can be 2 at the most. All right, so if she's at 209, if she's at 209, x would be 209. 209 minus 207 is 2, absolute value, so that works, okay? And then 205, if we put 205 in there, 205 minus 207 is negative 2. The absolute value of negative 2 is 2, so that would work too. This is called an absolute value equation. Sometimes they're a little challenging to set up, I'm not going to lie. So you got to just pause for a second and think about, how did I figure out these numbers? Well, I started with 207 and then I went up or down. And then that difference needed to be 2, no matter whether it was positive or negative. Okay, so let's look at solving absolute value equations now. So here we have 3 examples. I'm going to zoom in on this first one so that we can focus on it for now, just the first one. All right, the absolute value of x minus 5, that difference needs to be 3. Okay, so there's a way to do these, but I also want you to understand why we're doing it, of course. This center section, x minus 3, could be 3, and then we'd have the absolute value of 3 equals 3, check mark, right? If that came out to be 3, if that the x minus 3 came out to be 3, we'd be good, thumbs up. X minus 3 could be negative 3. So the absolute value of negative 3, because if that happens, that equals 3, check mark. So in other words, the middle part, sorry, this should be 5, right? You all are confused and not even listening to me probably because I goofed up. So x minus 5 could be 3, or x minus 5 could be negative 3. And if that happens, we've got a winner. We found an x that's a winner. So the middle part, once you do the calculation, could be 3 or negative 3. So that's why we're going to set it up like this. Absolute value equations branch out. So you're going to branch them out. You're going to branch them out into 2 equations. X minus 5, let's see if I can get the number right, could come out to be 3, or x minus 5 could come out to be negative 3. Okay, so then you solve the equation. We talked about this before. Add 5 on both sides, so x could come out to be 8, would work. Now you might think negative 8 is the other answer. That's a common mistake, is to jump to the assumption, and it's not. Watch, add 5 to both sides, x equals 2. There's your 2 answers. So you have to branch it out into 2 equations, and then you work them out using the both sides work that you learned in Algebra 1. Let's look at number 2. You might want to pause the video actually and just give it a try, because that's what I would do in class. Is I would say, okay, I want you guys take 2 minutes and try, and I'll be walking around to help you. Well, I can't exactly walk around to help you, but you can pause the video, and then I'm going to go through it here next. And we're back. Okay, so we're going to branch this out because it's an absolute value equation. So this is the process. Even if you didn't understand what I said about the whole middle could come out to be 6 or negative 6, I'm going to branch this guy out into 2 equations. The soft and chewy center, I like to call it, that middle part, could come out to be 6, or it could come out to be negative 6. Either one would be super, and we'd have an answer. Now you just do the both sides work and solve. Try not to do it in your head. Show your work so you don't make a silly mistake. 2x equals 10. Now how do we get rid of the 2? I hope you didn't say subtract 2, because it's attached by multiplication. So we have to divide by 2. I know we're all a little rusty here, so that's why I wanted to throw that out. Okay, so x equals 5 is one of the answers. On this other one, I'm going to add 4 on both sides. I get 2x equals negative 2, divide by 2, and I get x equals negative 1. So there's the answer on that one. So two answers, 5 and -1. And by the way, you don't always get a positive and a negative answer. You could get both positives, both negatives. Okay, so don't assume anything. You got to just branch it out and solve, and whatever the answer is the answer. Okay, we have one more problem to do, and this has a little curveball in it. So why don't you give it a try and see what you can do first? Okay, so the part that I've rewritten in red, we need to just hold off on that for a second. I'd really like to get rid of that +5. I'd really like to get rid of it. So how am I going to do that? Well, it's not part of that absolute value, so we can just -5, right? That'll get rid of it. And whatever you do to one side of the balance, you have to do to the other. That got drilled into you in junior high. So we have 6 equals. Now I'm going to bring down the other part here, x minus 5. Okay, from here it's super simple. All you do is branch it out. So once you get the 5 and the 11 together, which is not 16, by the way, right? We had a -5 on both sides, got 6. You just branch it out. X minus 5 equals 6. X minus 5 equals -6. See how easy that is? All right, let me get it out of the way there, my camera. All right, add 5 on both sides. I get 11 equals x. Add 5 on both sides. Careful here. X equals, this is a who wins by how much game, right? That's how I think about this. I've got 6 negatives and 5 positives. Sounds like there's more negatives, right? They're all in the room being lumped together. So there's one more negative. So the answer is -1. I would encourage you to try to exercise your brain and try to do stuff like that without a calculator. If you want to check it with a calculator until you're certain you know what you're doing, feel free. But just try to exercise your brain a little bit. Okay, I've got a lot of strategies for how to deal with positives and negatives. All right, so that's done with the notes. You should have some work up there in Google Classroom. Good luck. Contact me either via email or Microsoft Teams if you have any questions. All right, take care, guys.